Hi, Algebra 2. This is a quick little explanation of the homework answers for Unit 11, Lesson 1. So we did reciprocal trig functions. I just wrote across the top of the page just our basic trig functions from last year that you learned in geometry. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So question 1 wants to know which ratio expressed the cosecant of A in the diagram below. Cosecant is the inverse of sine, so it equals 1 over sine. Since sine is opposite over hypotenuse, then cosecant will be hypotenuse over opposite. So I go to angle A, because it said cosecant of A, and I'm going to do hypotenuse, which is 25, over opposite, which was 7, and that would be choice 2. Number 2, you have to draw your own picture, so it's a little bit harder than number 1. So number 2, they want us to find the cosine of theta if the cosecant of theta equals 13 over 5. So just like in number 1, cosecant is the inverse of sine. It's hypotenuse over opposite. So that makes the hypotenuse 13 and the opposite 5, because I got 13 on top and 5 on the bottom. So hypotenuse over opposite. So I drew myself a right triangle, and I put theta here. And again, the hypotenuse is 13 and the opposite is 5. So I put 5 across from theta. 13 is the hypotenuse, so it has to go here. And then you can just use Pythagorean theorem to find this missing side of 12. So I did 5 squared plus x squared equals 13 squared. Or if you already knew it was 12 from the Pythagorean triples, then you could just put that right there. And then I want to find the cosine of theta. The cosine of theta, cosine is adjacent over hypotenuse. So adjacent is 12, hypotenuse is 13, so it's 12 over 13. Okay, so each of these I've highlighted the answer in blue. 3 is a similar problem in that you have to draw your own triangle. It's also a little bit harder because I have secant of theta is 1.25. So I did change that. I put that in my calculator and made it a fraction, and that's 5 over 4. So secant is the inverse of cosine. Since cosine is adjacent over hypotenuse, and secant is hypotenuse over adjacent. So basically, when I draw myself a right triangle, 5 is going to be the hypotenuse and 4 is going to be the adjacent. And then you need to find that missing side. So here's my right triangle. Here's theta in the bottom corner. Hypotenuse is 5 and adjacent is 4. And then this is going to be 3 because this is a 3, 4, 5 triangle. You can use the Pythagorean theorem if you don't recognize that this is going to be 3. And then I want to find the cotangent. Cotangent is the inverse of tangent. Since tangent is opposite over adjacent, cotangent is adjacent over opposite. So from this, I'm going to do adjacent, which is 4, over opposite, which is 3, and my answer is 4/3. In number 4, they want me to find the measure of angle S to the nearest tenth of a degree. So this is a problem that we did last year back in geometry, basic trig. So I'm going to, since this is opposite and this is hypotenuse, I'm going to use sine. So the sine of S equals opposite, which is 8, over hypotenuse, which is 17. Remember, when I don't have the angle, when the angle is the thing I'm trying to find, I'm going to do that inverse button on my calculator. So second sine 8 divided by 17 is 28. Number 5, I need to draw my own picture. So I want to find the other 5 trigonometric functions of theta if sine of theta is 4 over 7. So sine is opposite over hypotenuse. So I drew myself a right triangle right here. I have theta, opposite side is 4, the hypotenuse is 7. Off to the left here, I did the Pythagorean theorem to find this missing side right here. 4 squared plus x squared equals 7 squared. 16 plus x squared equals 49. X squared equals 33. X equals the square root of 33. And then once I put that in my picture, then I can do all of my trig functions. So cosine is adjacent over hypotenuse, radical 33 over 7. Tangent is opposite over adjacent, 4 over radical 33. I don't like to keep a radical in the denominator, so I multiply the top and the bottom by radical 33. So on top I have 4 radical 33, and on the bottom radical 33 times radical 33 just equals 33. So that's called rationalizing the denominator. I'm allowed to multiply the top and the bottom by radical 33 over radical 33 because that's really just 1. Cosecant is the inverse of sine. It's hypotenuse over opposite, so it's 7 over 4. You can either do it from the picture or just flip sine. Secant is the inverse of cosine, so when I flip this, it's 7 over radical 33. Again, I need to rationalize the denominator. I'm multiplying the top and the bottom of this fraction by radical 33. So the top is 7 radical 33, and the bottom is 33. I get that because radical 33 times radical 33 is 33. And cotangent is the inverse of tangent, so I just flip this and I get radical 33 over 4. Six-year trig problem like what we did last year. You have to draw your own picture. I have a 20-foot ladder leaning against a wall. So the ladder is going to be your hypotenuse. It's leaning. It reaches to a height of 16 feet. So the wall right here is 16 feet. And I want to find this angle to the nearest degree the ladder makes with the ground. So this is opposite in hypotenuse. So I'm going to use sine. Sine of x equals opposite over hypotenuse. When I don't have the angle, I'm going to do that inverse. X equals sine -1 of 16 divided by 20, and I get 53 degrees. 7 is another one where I'm going to draw my own picture. I have a tree. It casts a shadow that's 20 feet long, so my shadow is always going to be on the ground right there. And the angle of elevation is in the bottom corner of your triangle, is 66 degrees, and I want to find the height of the tree. So my height of a tree is going to be this vertical line right here. This is opposite, this is adjacent, so I'm going to use tangent. Tangent of 66 equals opposite over adjacent, x over 20. I put a 1 under here, I cross multiply. 1 times x is just x. Tangent is 66 times 20. I put that into my calculator, and I get 44.9 or 45 feet. Okay, and those are the answers for lesson 1.